In this video, we're going to be building on our previous rules with exponents. In particular, now we're going to learn what to do when we're dividing with exponents. Now, if you're following along with IXL, this will set you up really nicely for V.5. So again, for IXL, this corresponds to skill V.5 in algebra. All right, so let's dive in and look at these couple of examples. First thing, let's take a look at this one right here, where we've got 7 to the 5th divided by 7 to the 3rd. Now, I could certainly multiply these out, but these are going to start to get to be pretty big numbers. So let's see if we can figure out a shortcut that makes it easier to work with exponents when we're dividing. In particular, let's multiply this out. 7 to the 5th. So I'm going to write this in expanded form. Whoops, that's not right. Not 7 times 5. I actually don't do 7 times 5. That's exactly what we don't want to do. It's 7 times 7 5 times. It's kind of funny I did that. So we got 7 times 7, right? 5 times, and then 7 times 7 times 7. Again, 7 to the 5th means multiply 7 5 times. Now I do see something I can simplify right off the bat. Right? I don't have to multiply all these out. I can cancel these, right? This 7 cancel, that 7 cancels, that 7 cancels. And what I'm just left with is 7 times 7. So I get 7 squared. Now, again, I can take that one step further, but today we're not going to actually try to evaluate. We're just looking for some shortcuts, some ways to simplify these expressions. Okay, so let's look at our next one. C to the 4th divided by C. All right, well, okay, this time it's a variable, but should be able to do the same kind of thing, right? C times C times C. So C times itself 4 times divided by, well, C, that's like saying C to the 4th, so it's just C. Again, let's cancel. The C's are gone, and I just end up with C to the 3rd. C to the 3rd, okay. All right, so far so good. Finally, let's take a look at this guy, which is going to be 5 to the 4th over 5 to the 6th. Again, I could multiply these out, but the numbers are starting to get big. It's sure a lot easier if I can simplify it first. So let's try to figure out how we might be able to simplify this. How about 5 times 5? So we're going to multiply 5 4 times, and same thing, but this time 6 times. So 6 times. We're going to do the same thing we did a minute ago. Let's try to cancel, and boom, 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 boom. Look, I've got over 5 squared, right? So I could write this as 1 over 5 squared, but remembering our use of negative exponents, I could also write this as 5 to the negative 2, right? There's going to be times where we want to keep it positive. There's going to be times where we just want everything in the numerator. Depends on the situation. One might be easier than the other. Okay, so, well, we've got some examples. Let's look for some patterns here. Look, I had a 5, a 3, and a 2. Well, how can I take a 5 and a 3 and turn it into a 2? Well, one way to do that is to say 5 minus 3 equals 2. Well, that's true, right? Okay, let's look at this one. I've got a 4. Now, technically, this is C to the 1st power, isn't it? You can think of it that way, too. So I could have gotten to this 3 by saying 4 minus 1 equals 3. Well, kind of doing the same thing. Look, I got a 4 and a 6 and a negative 2. I could take a 4 and a 6 and get to a negative 2 by saying 4 minus 6 equals negative 2. So sure enough, what we see is that when we are dividing, when we have exponents, we take the exponent of the numerator minus the exponent of the denominator. Now, really got to emphasize, notice that these are the same bases. This only works because both these bases are 7, both these bases are C, both these bases are 5. Don't get carried away and just start mixing and matching bases. You always got to do this with the same bases. So here's our rule for today. So b to the m over b to the n. And again, you got to keep this clear. We're talking about the same bases. But if you have the same bases, then it turns out in general b to the m over b to the n is b to the m minus n. Okay. One little thing that we got to keep in mind though, this really only works though if b is not equal to 0. b is equal to 0, things get a little messy because that doesn't always work out. So make sure that b isn't 0, make sure that b is the same, and then we've got this really cool shortcut we get to use. All right, so let's move on. So the next step is let's do a few problems. Right now, again, I just kind of rewrote our little rule up there, and let's use it. Okay, so again, 6 to the 9th, 6 to the 5th, that'd be a lot of numbers. Let's not do that. Let's just use our rule up here and just say 6 to the 9 minus 5 equals 6 to the 4th. Now, if I want to know the exact value, sure, I'd multiply that out. But sometimes we just want to get this far and be done with it, right? And so that's what we're doing right here. And again, I want to emphasize with these problems, let's really pay attention to what our instructions are. Notice we're going to rewrite these with a single positive exponent. Okay, this again depends on the situation. Sometimes you don't care about the positive part, but for these problems, that's what we're going to do. All right, let's take a look at another one. Okay, this time x to the 7th over x to the 10th. Okay, same thing. Let's say x 7 minus 10. 7 minus 10. Now that's x to the negative 3. All right. There are times where I'd like that answer, but in this situation, we want a positive exponent, okay? Well, okay, so what I have to do is rewrite that as 1 over x to the 3rd, x to the 3rd, right? Okay, let's keep going. Now we've got n to the negative 2 over n to the 5th, all right? N to the negative 2 over n to the 5th. Well, okay, so again, we're gonna use the same little formula there. I've got n to the negative 2. Now again, 5 is in the denominator, so I have to subtract it. N to the minus 2 minus 5, right? That is n to the negative 7. But again, I wanted positive exponents in this situation, so I'm going to rewrite this as 1 over n to the 7th. All right. Finally, let's do this last example here. And for this one, this time that's kind of interesting. I've got a negative exponent in the denominator. So again, as long as we're careful with our calculations, we're going to be all right. Y to the 3 minus negative 6. Notice it's minus a negative 6, right? Now, you might just, say plus plus in your work. I'm just going to write it out just to make it really obvious what I'm doing here. So this would just become y to the 3 plus 6, right? Y to the 3 plus 6, which is just equal to y to the 9th. Okay, awesome. All right, finally, let's move on to some problems that are just a little bit harder. Now, for these problems, we're going to have different variables all kind of mixed together. Now, again, same deal as before, right? We're going to simplify each, and for this particular situation, we want to have everything as a positive exponent. Okay. Again, there are times where we're okay leaving it negative, but I will say more often than not, it's clearer if we can turn things into positive exponents. So that's why we're going to do that right now. Okay, so just like we did in a previous video where we were, and I'll just cover this so we don't get confused, where we had multiplication with different variables. We're going to group these by variable, right? So notice here, right, I've got A's, those get grouped. The B's, on the other hand, they get grouped, okay? So let's keep those separate. So what I end up writing is A, so that's my first base, right? My A's are going to be, in here, maybe I can, let's see, sort of covered up, right? Just think about the A's right now. I've got A squared divided by A minus 5. So just think about that part. Okay, so this is A to the 2 minus a negative 5, right? Minus a negative 5. Okay, times, now I'm just going to think about my b's. B to the negative 3 divided by b. Okay, well that's like saying b to the negative 3. And this is, again, we're going to use this little shortcut, right? Or other way of thinking about it, this is b to the first, isn't it? Negative 3 minus 1. Okay, negative 3 minus 1. Now, I can simplify this, right? Minus a negative is like plus a positive, isn't it? So this is a to the 2 plus 5, which is just equal to a to the 7th. This, negative 3 minus 1, well, that's just b to the negative 4th. But again, remember, I want positive exponents, so this becomes a to the 7th over b to the 4th. And okay, let's do the same thing over for this guy. Same thing, right? We're going to group by bases, right? C, we're going to put all the C's together, we're going to put all the D's together. So I've got C, and this is 0, right? So 0 minus 3. Now technically C to the 0 is a 1, so I could also think of it that way, but it turns out the formula works just fine if I just call it a 0. So you can really do it either way. Times, now let's think about what's happening with D. D to the 4 minus a negative 2. Right? Minus a negative, right? Minus a negative is like plus a positive, isn't it? So this becomes plus plus, right? Okay, so let's keep working down. Now again, I find when I have multiple variables, notice I kind of laid this out a little different. I usually find it's a little easier to kind of work vertically, right? In the previous page, we were just working horizontally. With one variable, horizontal is fine. When you got 2, 3, 4, it's better to me if you just kind of work down. That way you can kind of just think about one thing at a time, right? I'm just thinking about A's here. I'm just thinking about B's here. So just visually makes it easier. Okay, so let's keep going. 0 minus 3, right? C to the negative 3rd. D, 4 plus 2 is, of course, 6. So D to the 6th. Positive exponents. I can't stop here. C to the negative 3. The C has to go down below. So I have D to the 6th over C cubed, right? All right, finally, let's do this. I'm going to give you a table that I'd like you to put in your notebook. This summarizes all these exponent rules we've done so far, okay? Now, let's quickly review. Now, in a previous lesson, right, we had the multiplication rule, right? B to the m times b to the n, and again, remember these all have to be the same exponent. Notice b is the same. Then it's just b m plus n, right? You multiply exponents, or multiply powers, that is, you add the exponents. If you divide, on the other hand, b to the m or b to the n, you're going to subtract the exponents. A couple things just to remember, sort of as a side thing, right? B to the 0 equals 1. And then also, this is related to dividing. You can think of b to the negative as n as 1 over b to the n, or similarly, if you've got a negative exponent in your denominator, you can bring it up to the top as a positive. So that sort of goes along with this. In a future lesson, we're going to talk about something called the power rule, but when you have a power to a power, I'm not multiplying, notice it's b to the m to the power of n. Just leave that blank for now, we're going to fill it in later. But it's nice just to have these all in one place. Also notice a little bit of a caveat, most of these require that b isn't 0. So just kind of write that to the side. If b is 0, you got to be careful. Some of these aren't going to work. But for any other base, you're just fine. All right, that's it. Again, make sure you copy this down in your notebook. And we'll be looking forward to meeting you with a future video so we can figure out this. Talk to you later.